Hello, in this video we are going to go over the solution of the problem 198, house robber, and we are going to use dynamic programming. The statement of the problem is telling us that we have an array and we are going to get the maximum value out of this array by considering different elements. But we have a constraint that we could not have two adjacent array elements. For example, considering this array, one possible solution is if I get the values 7 and 3, and because those are not adjacent array, and the output will be 10. But the other possible solution is if I get the elements 2, 9, and 1. The summation is 12. And we are going to return 12 as a solution of this array. Okay, let's start writing the code. The first thing that we are going to do is to create an array like this. So I can say n equals length of given array to us, length of nums. And then I'm going to create that max gain and say max gain equals none times n plus 1. Okay, let's run it. Right now I have created this array that the size of that is 1 more than the size of the nums. So I need 1 empty spots here. Next we define value for the element n of max gain and say max gain n equals 0, and also I'm going to define the element n minus 1 and I call it now. What was the n minus 1? N minus 1 will be the n minus 1 of the nums. Say nums n minus 1. Let me print max gain again here. Let's see what happened. So last element we just put 0. Now I have 1 as the, because here it's 1. So this, I turn this one 0 and this one as 1. Okay. Now I'm going to start a for loop and say for I in range of, I'm going to move backward from n minus 2. This is n minus 1, n minus 2. Okay. So I'm gonna say n minus 2 all the way to the index 0. So I'm gonna put minus 1 here because you know the minus, when you put the minus 1 it's not included, so it's gonna be all the way to 0, and it's backwards. You put minus 1 here, and let me also print I, and inside the for loop I'm going to follow this formula and say max gain I equals maximum between two things. The first thing is nums at I plus maximum gain at I plus 2. The next one is maximum gain at I plus 1. And at the end I just return max gain and max gain first element. Okay, let's run it and print some middle sections. If we do that, we see, okay, at the beginning we had an array 27931 and we created this maximum gain. Then here we initialized last two elements 0 and 1 here, and then inside the for loop for I equals 3 we start the for loop, and for that one, what is the nums at I equals 3? So that should be 0, 1, 2, 3. That's 3. And max gain I plus 2 is 0 because that is here. I plus 2 is 5. It's a 0, 1, 2, 3, 4, 5. That's 0. Okay. And max gain I plus 1 or max gain 4 is 0, 1, 2, 3, 4. That is 1. So considering that formula of comparison that we have, this formula here, so we are comparing the summation of these two numbers to the third one. and 3 plus 0 is greater than 1, so we are going to keep the maximum one in the max gain I3. So our max gain now updated to this. So the third element, so the index 3, 0, 1, 2, 3 is now 3. Then we go for I equals 2. For I equals 2, what is the nums I? So that is 0, 1, 2, that is 9. Okay. Maximum gain at 4 is 0, 1, 2, 3, 4 is 1. And maximum gain at 3 is 3. So the summation of 9 and 1 is 10, is greater than 3. So we are going to update the index 2 of max gain as 10 here. Then we go for I equals 1. For that one, nums value is 7. The max gain for I equals 3, 0, 1, 2, 3 is 3. And the max gain of I equals 2 is 0, 1, 2 is 10. So they are equal. So we just update the max value, which is 10, for the index 1 of the max gain. So here, that's going to be 10 now. For the last iteration, I equals 0. Nums of I equals 0 is 2. Max gain of 2, 0, 1, 2 is 10. Max gain of 1 is also 10. So 12 is greater than 10. So I'm going to update the max gain at 0 index at 12. And that's the value that we are going to return as the maximum gain that was possible to get out of this array. Okay, now let's talk about time and space complexities of this problem. For the time complexity, we have a for loop and we are visiting each element only once. As a result, the time complexity is order of n. The space complexity is also order of n because of creation of that max gain that we recorded all of the results of the comparisons. As a result, the space complexity is also order of n. We can also solve this problem with a space complexity of 1 with a little modification. So here for the last element of max gain, I can just call it as the variable third and put the value 0 for that. For the one value before that, I call it second with the value of nums and minus 1. So I can replace this one and this one. I don't need this one anymore. And inside the for loop, first equals maximum between nums at I plus third and comparison to the second. And then I need to update the third as second. I'm going to move one backward and second as first. And at the end, I just need to return first. And I don't need this line anymore. So if I run it, I get the value 12. In this way, I could have a space complexity of 1. Now let's talk about the solution of the problem 213, house robber second. And this solution is very similar to the solution of the problem 198, just we need a little modification. The new constraint is telling us that the first element of the array is also connected to the last element. So the solution is very easy. We just need to consider two different situations. One situation is from here to here. So from 2 to 3, I search one array and I record the maximum gain. And then I search from 7 to 1. So that is the exact same solution, just we need to have two values to be checked. And for doing that, we can just modify the code like this. So in the solution, now I have two functions. The first function is exactly the same as 198. So I have a function rob that gets a nums as an input and is going to return the maximum gain of that. So inside the rob second, we are going to have a max as it's going to compare two things. One is the array from the beginning up to here, one before the end, and the other one is going to start from the second element up to the end. And that comparison should tell us the solution. For example, for this array, if we consider, so one possible solution could be 2 plus 9, which is the maximum gain. That's going to be 11. So the other solution could be 9 and 1, which is 10. It's less than 11. So, or we could have 7 and 3, which is 10. So as a result, the output should be 11. Let's run it. And we get 11. The time and space complexity are also exactly the same as 198 because we just added this function rob2 here that it's not going to add anything in terms of time complexity or space complexity. Okay, this is the solution of the problem 198 and 213, house robber 1 and 2nd, and thank you so much again for watching this video.